Hi everyone and welcome to today's webinar. I'm Timothy Hammond from C.R.Kennedy and I'll be conducting today's presentation. So today we're going to be having a quick introduction into the P4 RTK as well as DJI's Terra software, and then we'll move on to connecting the Phantom 4 RTK to a Network RTK reference network and followed by processing the data in PIX4Dmatic. So a couple of the key parameters of the Phantom 4 RTK is its ability to have a 30-minute flight time, up to 7-kilometer transmission distance, as well as its centimeter level positioning system. And the idea behind the Phantom 4 RTK was to take out the need to put GCPs on the ground, and through this you drastically improve the surveying efficiency. So like with the P4 Pro, on a fairly large scale mapping site, you need to put between 8 and 13 GCPs down. With the RTK, you can get away with using 0, although if you want to increase the absolute accuracy of the data set, then it's recommended to put around 5 down, but still that's quite a significant time saving. All this data is actually captured through the 20 megapixel 1-inch CMOS sensor, and it has a global mechanical shutter. So all this is combined together with DJI's new time sync system, which I'll talk about in a sec. So the time sync feature, it's all about getting the most accurate data from the photo. And the new time sync system, which is incorporated into the P4 RTK, is designed to continually align the flight controller, camera, and RTK module. So why is it needed? It's because there's actually a physical distance between the flight controller, the CMOS sensor, and the RTK module. Precise exposure time needs to be aligned with the photo to ensure that you get the most accurate data in post-processing. Now, the key benefits are ensuring that each photo uses the most accurate metadata, we're talking millisecond level, whilst fixing the positioning data to the optical center of the lens, as well as optimizing the results from the photogrammetric methods. So what is an orthomosaic image? It's actually known as an ortho image or an orthophoto or autophotograph, and it's a high resolution aerial image taken by the drone. So this is stitched together using specialized software through a process called orthorectification. And this creates a highly detailed distortion-free map. And this is not normally, like if you're going to be doing just stitching a group of photos together, you're not going to get the exact same image that you will through orthorectification. And it does this by removing this perspective from each individual image to create consistency across the entire map while keeping the same level of detail from the original image. So one of the great things about the Phantom 4 RTK is not only the physical hardware, but the actual mission planning software. So whether it's a 2D photogrammetry model that you're trying to map, a waypoint, a linear flight mission, these are super simple and easy to select and achieve when you're out in the field. So what DJI previously released was the linear flight mission, which was if you wanted to conduct a power line inspection of a series of power lines, you'd set the flight height of the drone, it would stay at that flight height and just go and map the power lines, but that gave you an inconsistent GSD. So what they've now come out with is the linear flight adjustable height flight mission planning software. The idea behind the linear flight adjustable height mission is that not everything in the real world is completely flat. So what you'll want to do is select the first area that you're going to start mapping and then fly to the next point, which starts to have an increased elevation. And then you'll press C2, I do believe. Then you'll increase the flight height and continue flying the mission until you've saved all of the necessary height adjustments. Once you've saved everything and set the actual target surface height, you'll press Invoke on the drone and it'll return to the starting point. This will allow for the drone to continuously capture at an equal GSD above the power line or whatever you're going to be capturing. So for this example, we're capturing the car park followed by the roof of the building. So that's going to be a difference in height. So first off, we'll get the ground height for the car park, followed by the height of the actual roof that we're going to map. And so here we've got 3 or 4 different heights that the drone's automatically going to map and continuously follow the height of the actual target surface. Another cool new feature is the terrain awareness mode. So if you do need to do a site that has a difference in elevation, you go out, map it, turn it into a TIFF file, and then put it back into the controller of the P4RTK. Then once you get out to the site, the drone will automatically adjust its height above the surface to give you that equal GST. So previously it was hard to create really high 3D models, especially like the side of a building, where if you're flying high, you're not going to be able to get a nice side-on view of the building. So what DJI have done is created the new angled flight route. And this basically enables you to do a mission instead of flying horizontally, it'll fly up and down vertically to capture all the data that you need to create a 3D model. So this example may not be pretty, but it gets the point across at least. So you just select point A and point B at the same heights, and then point C would be the top of whatever you're going to be mapping. This is super useful, say if you're in a mine site and you need to map the side of a wall or the slope that you're digging into, because it saves the risk of sending someone to a potential danger zone, and you can get a high quality map straight from the drone just by simply tapping, in this case, a couple of buttons. And now we'll move on to DJI's Terra software. So it is an all-in-one platform which can support photogrammetry, LiDAR, and multispectral mission reconstruction, which is super convenient to have everything in just the one place.
So it's super easy to actually create a mission, and it's so much easier to use a computer before actually going out on site to see what you're going to be mapping. So in this scenario, we're going to do a real-time 2D mapping. You're going to select your mapping scene, so urban in this case. Select your mission altitude as you normally would for a flight. And then we're going to go to select the correct drone, in this case the Phantom 4 RTK, as well as selecting the correct white balance. And today it is sunny, so we'll click there. And then just like the GS RTK app that you use when you're out in the field, select as many points as you're going to map, and then DJI's Terra software will automatically plan a flight mission. So if you need to adjust any of these settings, just click on the Advanced tab. The main course angle, that's going to be the direction that the aircraft actually flies the route in. So if you want it to head north to east, east to west, it's pretty simple to change. The margin, if you want it to stay within the confines of the boundary, you're going to adjust this accordingly. But 0, it's not going to be anywhere outside of this square, and then you can go up to, I think, 25 meters or so, and that'll be outside of the actual square box. So good if you need to get the side of an actual, of a building, etc.
A pretty cool feature of DJI Terra actually is the real-time reconstruction, and this is done. It creates an automated flight mission of the affected area. So whether this is like an accident or whether there's been flooding or a natural disaster, and it's going to provide greater situational awareness for the team on the ground, because time is of the essence. So because first responders want to know what happened and why it happened. So if they can capture this data, say if there's a crash on the road, they don't want to be blocking the entire highway for a significant period of time, taking photos manually. What you do here, you just select the area that you want to map, and then DJI's Terra software will automatically create a flight route to ensure that all the photos that you need are captured. So there are a couple of different ways of actually going out and collecting data with the P4RTK. You can go out with the DRTK2 base station made by DJI, or in this case, what we're going to focus on today is connecting the drone to a CORS network correction system. So what's the difference between RTK versus Network RTK? Well, put it simply, the drone uses GPS to take georeferenced images. A GPS position on its own is only actually accurate to a few meters. So we use a second GPS receiver to correct this position down to a few centimeters or even a few millimeters. The drone uses the internet to obtain the correction from other GPS via the internet in real time as it's flying, using real-time kinematic or RTK GPS. However, as the distance between the drone and the GPS base increases, so do the errors. Therefore, we use a network of reference stations to cover a large area and a variety of methods and algorithms to send the drone to the best solution at any given time. And I guess the great thing about this is that you don't actually need to set up your own base station, which probably halves your capital investment already. So the other benefits are you don't need to purchase a base station, no need to configure or learn how to use the base station. The accuracy is maintained over large distances between the reference stations and the rover, and you get a higher reliability and availability of RTK corrections, i.e. if one base station goes down, then another can take over. So the reference network that we're going to focus on today is Hexagons Smartnet Oz network, and they have more reference stations than any other GNSS correction service provider around the world, which means you're going to get incredible accuracy and reliable coverage basically wherever you are. The precision GNSS positioning gives you location accuracy down to the centimeter, and the exact precision, reliability and predictability that you will need for machine control and automation, surveying and asset mapping. Another few benefits of Network RTK is you don't need a whole lot. You just need access to the internet. So whether that's with Fender 4 RTK, a 4G dongle, ZTE in this case, or the ability to hotspot from your personal phone. As well as that, a subscription to a good network RTK provider isn't necessary, but it does have its definite advantages. So to connect the RTK to the corrections network, we're going to go into the RTK settings, which is in your Fly homepage, and we're going to go to Custom Network RTK, and then we'll enter the following values.
So to get the SmartNet logins, you'll just go to your customer login page here. And this is the screen that you'll be greeted by. You can see all their base stations around Victoria, New South Wales, South Australia. So once you know the rough area of where you'll actually be operating in, you'll select the base station by clicking on one of the icons. And this is the screen that will show up, giving you some more information about the actual reference station that's sending the drone the corrections. Now to get the actual specs that we talked about before, to enter them into the device, you're going to go to the left-hand side of the screen here under Mount Point Configuration.
So on this page, you're going to select your location. In this case, we're in Victoria. Followed by your datum, so whether it's GDA 94 or GDA 2020. Then we're going to select survey, agriculture or Xeno. In this case, we're going to be selecting survey. Followed by what type of format you are going to be recording in.
Now, the final option is the type of corrections that you need, whether it's going to be IMAX, which will give you an average of corrections from a number of surrounding reference points,
or nearest base, which will give you the corrections from the nearest base station. But that means if you do move the drone into another area that's closer to another base station, it will switch over. So just be aware of that.
Or single base station, which will provide the corrections only from the one base station you've selected. So if you select this, you will need to go back to that screen that we looked at before, and on the reference station, it's going to have your site code, which is what you'll use when you're inputting on the mount point. So in this case, it's C.R.K.M. So a lot of people wonder why you'd use a paid network subscription. And the benefits of this are that companies like C.R.Kennedy, they're actually able to log into the network interface to see where your rover is and ensure that all the information inputted is correct. So if you send a new employee out onto site, they think that they've captured all the data, then they take it back home and they've actually inputted something incorrectly. The best thing they can do when they're out on site is actually call up CRK. They can log in, check to see that everything's right, and then you can ensure that you're doing that you're actually capturing the required data successfully. So once we've got all those inputs, we're just going to enter them. They should be entered here. You're going to click on the connect icon, and hopefully the custom network RTK status will say connection success. It may take a minute or two depending on where you are, so just be patient. You're going to want to make sure that the position is set to fix. I think before it should be saying single, and then you'll start receiving data from the actual reference station, so you can see its latitude, longitude, and altitude, as well as how many satellites it's getting, and then your standard deviation of these down the bottom.
If you do need to check that the RTK network is set up properly, you can just click on the RTK Diagnosis button, which will show you green bars between your aircraft remote and the custom network. If something is red, maybe just go back to where you entered your values before and double check that you have entered it correctly, because it is case sensitive. So once you've obtained a successful connection to the internet and everything's looking good, it's now time to go out and fly the actual mission. Unfortunately, due to a lockdown where we are located in Victoria, this has been a little bit hard. So we just got a sample data set from PIX4D, and we're going to process that shortly in PIX4Dmatic. So now on to what PIX4Dmatic is, and it's a software optimized for accurate and fast photogrammatic processing for corridor and large scale mapping. It's designed to handle and process thousands of images with ease while maintaining survey grade accuracy. And the difference between PIX4Dmatic and PIX4D Mapper is that for datasets, large datasets of, let's say, more than 5,000 images, if you're taking them with nadir or slightly oblique camera positions, with the standard camera resolutions of between 12 and 42 megapixels, PIX4Dmatic is going to be way faster and more reliable than PIX4D and other software in processing. A cool feature of PIX4Dmatic is that you can actually create projects using images from different cameras, as well as you can take photos in the nadir format or slightly oblique. So you're not just limited to a 2D orthomosaic. And then, as you'd expect with PIX4D, you can import and mark ground control points to improve the absolute accuracy of the project. So the workflow is super simple. Simply drag and drop the photos into PIX4Dmatic. So once all the photos are imported into PIX4Dmatic, the flight route will be generated, as well as you'll be able to see all the different camera angles that were taken for the data set. At this point, as well as on the right-hand side, you've got each individual, so if you individual photos, so if you do double tap that, you can bring up a full-size image that you've taken. It's at this point that you'd actually drag and drop the ground control points into the software, and then you double check just to make sure that they do match up with what you're seeing on the screen. So depending on your requirements, you can either select nadir or oblique. In this example, we're going to calibrate the camera, as well as create a dense point cloud. In addition to this, we're going to create a DSM, digital surface model, as well as an orthomosaic. And we're going to also select to get a quality report made for us. After that, we're simply going to click start and wait for the processing to happen. So after PIX4Dmatic finishes calibrating your camera and generating the reconstruction, you can take a look around the project area and you can enable and disable what you see by clicking on the left-hand side, just the eye icons. So in this case, we're looking at the dense point cloud. So in addition to this, you've also got the 2D high definition Orthomosaic, which has got all your high resolution photos stitched together. And this is great for future planning, like if you need to export it into a CAD program, then you can do so, which will give you a greater view of what you're actually going to be planning on. As well as this, you've got the DSM or digital surface model, which is great for being able to know the lowest point in a map. And so if you're planning for floods, etc., then you'll be able to see where the water is most likely to collect. So once you've had a bit of a play around with the model and reconstruction, you can click on the right-hand side to get the quality report. And so here you've got the calibrated images, which is the number of images that PIX4Dmatic actually calibrated for the model. After this, we've got the average ground sampling distance taken of the images, and then the root mean squared of your GCPs. So that's one of the benefits of the P4 RTK, is that it eliminates the need to have excessive amounts of GCPs for a model. And finally, you've got the difference between the initial and computed internal camera model parameters. If you do have a PIX4D survey license, you can also open that, and that'll open the exact same model straight on your desktop. But if you don't, and you do need to export to third-party software, this is also achievable. All right, so that pretty much sums up today's webinar. But if you do have any questions, or you need any further help on any of the subjects that we've touched upon today, feel free to email me at thammond@crkennedy.com.au, or you can also email sales@crkennedy.com.au. And there's quite a few people here to help assist with your needs. Anyway, thanks for listening, guys. And yeah, we will be around for a little bit longer if you do have any quick questions that you'd like to type in the chat now.